Alright, let's sketch the function f of x is equal to negative 2 x minus 1 squared plus 3 with attention to domain and range, intercepts, point of extrema, and the intervals of increase and decrease. Okay, so we know that by looking at this, it's a quadratic function. Specifically, this is a quadratic function in vertex form, and we know that the vertex is going to be in the form of h and k, right? So in this case, you have 1 and 3. So what I want to do here also is I also want to kind of assess, the a value. The a value here is going to be negative 2, and a is less than 0, so it's going to be concave down, right? So if I create my grid here, okay, so once again, this is going to be like a sketch. So because it's a sketch, we don't need to actually put some points, but because it's in the realm of our grid sheet, we should be okay. I'm going to do 1 and 3 here. So it's going to be in the first quadrant, right? And because we know that the x value of the vertex is 1 and 3, and the x value of the vertex is 1, this is where our axis of symmetry is. Remember that the x value of the vertex is the axis of symmetry of your quadratic function, right? So now that we figured out the x value of the vertex, because this is concave down, you can understand that there is a maximum point at 1 and 3, right? Specifically at 3, right? So when y is equal to 3, that's a maximum point. So just off the bat here, we know that the domain of all quadratic functions, x belongs to the set of all real numbers, right? But the range of the quadratic functions, y can belong to a set of all real numbers such that, that's what this line means, such that y is less than or equal to 3, right? So y has to be lower or equal to the maximum point, hence why it's called the maximum. Now let's take a look at the intercept. So let's start with, because we can see here that our graph is going to basically go down, right? It's going to hit a certain value, and it's going to hit the x-axis at some point, right? So I'm just going to sketch this. I don't need to look at actual values, but if we're looking at intercepts, I'm going to start with the y-intercept, right? Because it's going to hit some kind of point on the y-axis, and it's going to hit 2 points on the x-axis, right? If I start with the y-intercept, if you want to solve for your y-intercept, you can let x equal 0. So if I let x equal 0, I'm plugging in 0 for x, so I'm doing f of 0. It's negative 2 times 0 minus 1 squared plus 3, which is negative 2 times negative 1 squared plus 3, which is negative 2 times 1 plus 3, which is 1. Okay, so f of 0 is 1, so technically the point should actually be there, right? So this is why, let me see if I can get that back. Right, so this is basically why it's good to kind of calculate this stuff, right? So you can know exactly where and how your graph is going, right? So it's going to hit this point 0 and 1, right? And we can understand that it's also going to hit 2 x values, right? So I'm going to erase that and that, so we can figure out what those values are. It's going to hit 2 x values. So let's figure out what those x values are. So if we want to find our x-intercept, you're going to let y equal 0. So if you let y equal 0, right, I'm going to let f of x equal 0. So if I let f of x equal 0, right, I'm just going to do this out here, you're basically going to get negative 2 times x minus 1 squared plus 3 is equal to 0. I'm going to move the 3 to the other side. Negative 2 times x minus 1 squared is equal to negative 3. And divide by negative 2 to both sides. Negative 2's cancel out. X minus 1 squared is equal to 3 divided by 2. It's basically 1.5. And then what I want to do here is I want to solve for x. I'm going to do the square root, right? The square and the square root cancel out. X minus 1 is equal to, because square roots are plus minus, I'm going to write plus minus square root 3 over 2. Move the 1 to the other side. X is equal to plus minus the square root 3 over 2 plus 1. Okay? So one of your points here is going to be negative square root 3 over 2 plus 1 and positive square root 3 over 2 plus 1. Okay? So if we wanted to actually find a decimal value of this, I can plug this in my calculator, so give me 1 second. Right, so negative square root 3 over 2 plus 1 is going to give us x is equal to negative 0.22 approximately. And positive square root 3 over 2 plus 1 is going to give us 2.22 approximately. Right? So this just tells us that this is basically negative square root 3 over 2 plus 1 and 0. Okay, so those are the coordinates. And then this point here is going to be, it's going to be about here. Right, so positive square root 3 over 2 plus 1 and 0. Okay, so, and that's our sketch basically. Okay, now what we need to do next is points of extrema. We found our point of extrema, and a point of extrema is a maximum minimum. That point of extrema here is our vertex. So this is our point of extrema. And the intervals of increase and decrease. So now we have a sketch, right? So we have a sketch, right? We have the sketch here, and we want to see that our interval of increase, which I'm going to do here, the interval of increase is going to be from negative infinity, so all of this region here, right, all the way up here, right? And the vertex here, this point here is 1, right? So the interval of increase is going to be between negative infinity and 1. And you want to use round brackets because at 1 you have a vertex, right? So it's not really an interval. So anything between negative infinity and 1, right? Because at 1 you don't actually have, it's not part of the interval. The slope or the rate of change is actually 0, right? So you learn this in studies of calculus, right? The slope, if you do a tangent to this point, it's 0. So that's why we're going to not include 1 in the interval. And if we're looking at an interval of decrease, which I'm just going to use blue for, right, you're going to see that actually here. So intervals are basically, you can use secants here, right? There's an interval of decrease, right, between, between 1 and positive infinity. Okay, so those are our two intervals. And that's basically a well-refined sketch of the function and a certain analysis of some of it.